Hi everybody, welcome back to my channel. We have a very interesting equation here, y equals x times e to the power of 1 over x squared, and we're asked to have a sketch of this graph. So as you know, when we're sketching, first we're going to find x, y-intercepts, if there are any asymptotes, the domain and the range, and then we're going to take the first and the second derivative, put them equal to 0 to find the maximum and minimum points as well as concavity changes through this graph. So in order to do that, let's just get started with the x-intercept and the y-intercept. So to find the y-intercept, I'm going to put x equal to 0, and if I do that, the whole thing, it won't exist because I have e to the power of 1 over x squared, and 1 over 0 doesn't exist. Therefore, my function won't exist at x equals 0. So right away, I know that at x equals 0, I will have an asymptote. So I will not be hitting this line at x equals 0. And also, I'm just going to put y equal to 0. So this whole equation is just going to equal to 0. And in order to make that 0, we need to either have x equal to 0 or e to the 1 over x squared equal to 0. I can't have x equal to 0 because we just established that we can have our function equal to 0, and I also cannot have e to the 1 over x squared equal to 0 because x could be anything. It could be negative 1000 and I will still have a number for e. It will never be 0. Therefore, I don't have any y-intercepts or x-intercepts in this case. All right, now the next thing I'm interested to find out is that what's going to happen to my function as I'm approaching the asymptote from the right and the left side. So you already know that we have to take the limit of the function as x approaches 0 from the positive. So for the function, I'm just going to write f of x here. And I'm just going to give it a number. So let's give it a 0.1, and then I'll have e to the 1 over 0.1 to the power of 2. And if I calculate it, so I'm not taking the limit right now. All I'm doing is that I'm calculating an f of 0.1. Okay, in this case, if I put it in my calculator, it would be a very, very large number, something about 10 to the power of 42 or 43. So I'll just have that approaching positive infinity here. And as I'm going to the left, since I have the x here, so all I'm going to change is that I'm going to substitute negative 0.1 here. And because I have an x here, and x squared is not going to change anything for this term, but it's going to turn the whole function into a negative because of the x that I have there. Therefore, the answer to this would be negative infinity. All right, so I know two very important things about the function. Now what I want to find out is about the domain and the range. So let's talk about the domain first. So for domain, I have x equals all real number. It could be all real numbers. It just can't be 0. All right, and in order to find the range for this function, I need to know where the maximum and minimum is, right? I can't just decide what the range is going to be. So let's go ahead and find maybe the first derivative of the function and then go from there. So the first derivative is going to give this a function for the slope as we go through the whole function at different points on the original function. So in order to do that, I have to look at my function here, f of x. And I have two terms, x and this, e to the 1 over x squared. Now this looks like a product rule, so I'm just going to take the derivative of that. It would be the derivative of the first function, which is x. The derivative of x is 1, times the second function, plus the derivative of the second function times the first function. So the derivative of the second function is e. So the derivative of e to the x is basically e to the x, and then if I have e to the 2x, then it would be the actual function times the derivative of what's on top, right? Which is 2 in this case. Now same thing here. if I have my function to be e to the x minus 2, the derivative of that would be the actual original function times the derivative of what's on top, which is negative 2x. Negative 2 minus 1 is negative 3 times the first function. So don't forget writing down the first function. Now let's just try to clean it up a little bit. So I have e to the, let's just write it like this, x to the negative 2. And then over here I have minus. I have an x to the minus 3 and an x here. So that would be minus 2x to the power of negative 2. And e to the x minus 2 will remain there. Now what I'd like to do here is that in order to simplify this, what I can do, I can take out and maybe factor out something. What do you think we can factor out here? I say we can actually take out e to the x to the negative 2, and I will be left with a 1 here and a negative 2 over x squared here. Okay, so that's my derivative function. Now there are other ways. So if you did this on your own, there are other ways to do this. How do we know we got the right answer though? If you can't see it visibly, what we have to do is to put this derivative equal to 0 and see if there are any maximum or minimum, and which means any slope changes, if my slope changes from positive to negative or vice versa. Now in order to have this equal to 0, this can never be 0 because I can't select x to be anything to make this equal to 0, but I can make this whole thing equal to 0. So I will write 1 minus 2 over x squared equal to 0. Therefore 2 over x squared equal to 1. 1 goes to the other side and changes the sign. And x squared is pretty much equal to 2. Therefore x is plus minus square root of 2. Alright, so we know that my slope, my derivative is equal to 0 at these 2 points. All right, so square root of 2 would be 1.4, so it would be somewhere here, square root of 2, and then negative root 2, so it would be 1.4 here. So at these 2 points, I might have a maximum or minimum here, so what I'll do is that I'll use my sign chart, add square root of 2, and then add negative square root of 2. I just need to give it a number before square root of 2, so let's give it a 1 and a 2 and find out what happens. So if I give my derivative function, which is y prime, a value of 2, what will happen? I will have 2 times e to the 1 over 4, and that will give me a positive number. And if I give my y prime a 1, in this equation I will have e to the 1 to the negative 2 times 1 minus 2, 1. So over here I'll have a negative number, so I'll have my function to be negative. Therefore my slope is going negative, and here my slope is going to be positive like that. Then I know that at root 2 I will have a negative. Since this is the same function on this side, if I give this function a negative 1, you can expect to get a negative function. And then if you give it a negative 2 to the y prime function, you'll get a positive function. Therefore, you're going positive and then you're going negative. You will have a maximum here. Now let's go back here. I made a mistake. So at y prime 2, I would have e to the 2 to the negative 2 times 1 minus 2 over 4, and that will still be a positive number. I just plugged it in into the actual equation, so my bad, please fix that. Now what I want to do is that I want to find the coordinates of my minimum and maximum, so then I'm going to substitute in the original function of my f of x my x values of root 2 and negative root 2. So I would have root 2 times e to the 1 over 2. That will give me 2.33. and then it will give me negative 2.33 here. Therefore, I know at 2.2 over here, I will have a minimum here. And same over here at negative root 2 and negative 2.33, I will have a maximum here. What happened to my point? Okay, great. So now that I know that, I just want to know if there's any concavity and be on my way. I'm just going to rewrite here my y prime function, and I will just use product rule to do this. Now, I have taken the derivative of this guy. This is e to the 1 over x squared. So the derivative of that from the previous part is just negative 2 x negative cube e x minus 2. You can definitely pause this video and do this on your own and then try to compare with your answers with mine. Now, you might not get the same derivative exactly like the way I do it. If you simplify it, you will get the same thing. Okay, so if you have this, then for the second part, I'm just going to keep the 2 outside. And then now I have a product rule between these two guys. Again, I know the derivative of the first guy, which is negative 2 x to the negative 3 e x to the negative 2. This is the derivative of the first guy times the second guy plus the derivative of the second guy, which is negative 2 x negative 3 times the first guy, which is e to the x negative. Okay, great. Now that we have this, all we need to do is to clean up a little bit and see if we can simplify. So from the first part, I pretty much have negative 2 over, let's write this in the bottom so we could see better, in case if we can take the common denominator. And then I'm just going to leave the 2 outside. I'm just going to work with what we have here. Now it looks like that I have a 2 and the e, a negative 2 and a e to the x negative to the minus 2 here, and then I have an x to the negative 3 and an x to the minus 2, which is x to the minus 5. Then I can bring it to the bottom here. And then for the second part, I also have a negative 2 e to the x minus 2 over x to the 3 this time. Now it's very easy to see that from the second bracket, I actually have 2 things that I can take out. So these 2 are in common. Therefore, I'm just going to write everything else here. I can take out the negative 2, so the negative 2 times this negative 2 here would be a positive 4. I can also take out the e to the x minus 2, and I can also take out an x cube here, right? So what I will be left with here, because I took out the 2, negative 2, and an e to the x, so I took out the whole numerator, I will only be left with a 1, and x5, it will be turned into x squared. And the second term is basically completely gone, and since I took out the negative, I'll end up with a 1, positive 1. Okay, now I could go ahead and factor out this term and write this a little bit more simpler. I'm going to factor that out. I'm going to factor out e x minus 2 over x cubed, and I also have another 2 that I want to take out, so I'll take 2 of that, and I will be left with pretty much a 2 from here, a 2 times 1 over x squared plus 1, and from here I will be left with a negative 1. Okay, so what do I have here? So I have 2x squared plus 2 minus 1. Therefore, this whole thing is going to equal to 2ex minus 2 over x cubed times 2 over x squared plus 1. Now, in order to put this equal to 0, all I need to do, since this can never be 0, I can take x to be anything to make this equal to 0. Therefore, I'm going to actually focus on this because if this bracket is equal to 0, this whole thing is going to equal to 0. Therefore, I'm just going to write it in a different color. I will have 2 over x squared plus 1 equal to 0. So this is 2x squared equal negative 1. X squared is pretty much equals to 2. So negative 2, and x is going to be plus minus minus 2. So this is not real. This is pretty much an imaginary number. Therefore, there are no points of inflection here. Okay, so since we know that the concavity doesn't change, I'm just going to go back and see and try to put everything together. So I know there's a minimum here. I know that I'm approaching infinity as I'm approaching the y-axis, positive infinity. And I also know that I'm not going to have any x-intercepts or any y-intercepts here. So I know that I'm going to look something like this as I'm approaching this guy. But what's going to happen as I'm approaching this guy, since I have no idea if I know that my concavity doesn't change, so my concavity has to remain up somehow, but I don't know exactly how it's going to go. Now I want to show you something very interesting about this graph, and I'm just going to draw it here so you can see it better. I want to give it a table of value and I want to see what's happening. So what I want you to do is to pause this video and start giving this guy x and find out what y it will be after square root of 2. So I want you to give it 2, 3, 4, 5, and 6, and you will get pretty much 2 times e to the 1/4, 3 times e to the 1/9, 4 times e to the 1/16, and so on. Now, if you actually calculate this, all of these are very, very close to 1. Therefore, when you multiply the coefficient to it, it would be very, very close to 2, very, very close to 3, a little bit over 3, a little bit over 4, a little bit over that. So you're basically approaching a y equals x line like that from both sides. And you're never going to cross it. Your x is never going to be equal to y, but it's always going to be, your y is always going to be just a little bit greater than x, which actually shows in the graph that I drew here for you. And well, this isn't bent, it goes like this. What I wanted to show is that this also mirrors it right over here, and that's pretty much everything you need to know to be able to give this graph a good sketch. If you have any questions, please comment them down below, and please like and subscribe as it motivates me, and I'll make more videos for you. Thank you so much for watching,